Welcome back, and in the last video we finished finding the vertical asymptotes in the holes, even though there was just one, for that function that we were working with. Okay, so now there's another type of asymptote that you can encounter, and it's called a horizontal asymptote. And so this video, it's going to look a little complex, but I promise you once you get a little experience, it isn't too terrible. Okay, so a horizontal asymptote, well, vertical asymptote when vertical, guess what a horizontal asymptote does? Boom. Okay. Now the trick to find them is actually it comes from calculus. So this this is a different representation of the rational function that we're working with. Okay. So we know that it's polynomial over polynomial, and so generally we can say that there's a degree n and then there's a degree m. They might not be the same. They could be the same. Okay. But then there's so n here is going to refer to the numerator degree, and m is going to refer to the denominator degree. Okay, so that we say p of x is degree n and q of x is degree m. Okay, and then to determine the HA, the horizontal asymptote, we actually use calculus. Okay, or a result that comes from calculus. Okay, so if n is less than m, that means that there's a horizontal asymptote at y equals 0. So this is numerator degree less than denominator degree. So we would see something, for instance, like x squared plus 1 over x cubed plus 2. Okay, something like that. Okay, that means that you're going to have an HA at 0. Next is if the degrees are the same, then it would be at the ratio of their leading coefficients. So for this example, let's think about something like, okay, we have y is equal to 3x squared plus 2 all over 4x squared minus 5. Okay, so we notice that the degrees are the same, right? So then there's going to be an HA at y is equal to 3 over 4. Okay, this is a line as well. It needs y equals. Okay, great. So moving on. If the numerator is the denominator degree plus 1, okay, that's the instance where we're going to have a slant asymptote or an oblique asymptote. Okay, a line, and you can get different shapes, but this is the most common one. So we're not going to deal with this in the course, but I'll say a few more words about that. More generally, if the numerator degree is more than 1 of the denominator, there's no HA. So this would be something like x cubed plus 3x plus 1 all over 3x minus 2. Okay, more than 2 apart, no HA. All right. So again, just to reiterate, the oblique asymptotes or slant asymptotes won't be in this course. If you need to find them, literally all you have to do is type the function into Wolfram Alpha. You all might use Mathway or something similar. Wolfram Alpha is more powerful and better, in my opinion. I'm biased, but whatever. But anyway, type it into Wolfram Alpha and then the word asymptote after, and it'll give you the asymptote without having to do polynomial division, which is what you normally need to do. Okay. And now one thing about horizontal asymptotes. Okay, generally you don't cross asymptotes. Generally. Okay, vertical asymptotes, if you cross it, that's not good because that means you have an undefined value. Okay, HAs, you can cross a horizontal asymptote, but for small values of x. And when I say small, I mean like something like from 10 to from like negative 10 to 10. So that's relatively small. Okay, in the view of infinity, yeah, that's small. Okay, but as you get further away from the origin, that's when it needs to hug the asymptotes. Okay, so moving on here, we want to be able to do this. Okay, here's our working example. Let's find the horizontal asymptote. If I look at this, let's see. So I see the numerator here is, let's see, degree 2. So then I'm going to have an HA at the ratio of their leading coefficients, so 1 over negative 1 in the denominator, or negative 1. But now I did this for f of x. Does it matter if I do it for r of x? Let's see. HA at y is equal to, okay, there's a negative out in front, the way I've written it, and then it's just 1 over 1. which is -1. It actually doesn't matter. I advise students to work with R of x whenever possible, just because it's simplified, right? It should be easier to work with generally. So there you go. You can find the HA. So again, here's an example that I want you to do as a quiz question. Actually, sorry, before we do that, I want you to just look at this graph. Here I've plotted the vertical asymptote and the hole down here that we obtained in the last video, and then now we have the nice horizontal asymptote shown too. Next video, we'll finish off this graph. Until then, really, this time, here's the quiz question.